This is Algebra 2, Chapter 5, Section 5. This is Part 4 of performing function operations. The last thing we have to do is function compositions, which you put one inside of the other. You'll see the little circle as the operation for denoting a composition. What's important here that's different is if it's not in the original function you plugged in, it can't be in the output of the final function. So it's like a turducken. Right? You can look that up if you don't know what turducken is. So if it's not inside the original you plug in, it can't be in the final product. So keep that in mind as we do these examples. Okay, so here we're only going to ask the domain, not the range. Okay, so let's say we have these two functions f of x, and I would do f of g of x is the way you read it. So that's f of g of x, which means take the f function to over x minus 1 and replace the x with the other function. So replace the x with the other function, which is 3 over x, because you're swapping the x for g, because g is going inside of it. Okay, so the problem is now we have a complex fraction, which is a fraction with fractions. I need to get rid of that extra denominator, so I'm going to multiply by x over x, which is 1, which will not change the problem. So what that does for me is it gives me 2x on top, and if I distribute this on the bottom, I get 3x over x minus 1x when I distribute. So as a result, I get 2x over 3 minus 1x. I no longer have a complex fraction. So that's the trick. Whatever the extra denominator is, multiply by that as a ratio of 1 to get rid of it. That is an Algebra 1 topic. So 3 minus 1x. So that is our composition of f and g. Okay, then we get to do domain. So you have a couple restrictions here. So again, you don't think about what you can be, you think what you can't be, because there are infinite things you can be. So are there any even roots here? No. Are there denominators? Yes. So 3 minus 1x cannot be 0, because I cannot divide by 0. So the question is, when is the denominator 0? So if I minus 3, negative 1x cannot equal negative 3. Divide by negative 1, x cannot be 3. So if I plug in 3 into this denominator, I will get 0, which cannot happen. Also, the original problem had an x by itself. That x can also not equal 0. So I cannot be 0, and I cannot be 3. So my domain is everything except those. So again, as I said, don't think about what you can be, think what you can't be, because what I can't be is a finite number of things here. So I go from least to greatest, so negative infinity to 0, and then 0 union 0 to 3, and then union 3 to infinity is the proper domain for this function. So I have a whole, or asymptote rather, at 0 and negative 3. Okay? Alright, pause the video, try student problems for yourself. Alright, function composition of f of g. F of g of x. So we take f, we get 4 over x plus 2, but we're replacing the x with the g function, right? We're putting in one inside the other. So 1 over x. So I don't want a complex fraction, so I'll multiply by that extra denominator as a ratio of 1. So that gives me 4x when I distribute. And distribute on the bottom, I get 1x over x plus 2x. All right, I'm going to distribute. So simplified, I get 4x over 1 plus 2x. So my actual function composition is 4x over 1 plus 2x. Okay. Alright, so now we need to do domain. Are there any even roots or any denominators? There are no even roots. We do have a denominator. This denominator, 1 plus 2x, cannot be 0, because you cannot divide by 0. Minus 1. 2x cannot be negative 1. Divide by 2. X cannot be negative 1/2. Also the original one, x cannot equal 0. Because again, turducken, if it went in the original, It can't be in the final one. The original one was 1 over x. That's what you plugged in. So it cannot be either. So my domain, going left to right, least to greatest, I go negative infinity. The next one is the negative 1/2 union negative 1/2 to 0 union 0 to infinity. Okay, and that is the end of part 4.